Hello friends, today we're going to talk about thermistors and RTD. We're going to talk about the types, the working principle, and the comparison between thermistor and RTD sensors. So first of all, what is thermistor? A thermistor is a sensor that can measure temperature based on the resistance changes when the temperature changes. So thermistor comes from the word thermally resistive resistor. So the key feature that we're going to discuss is the non-linear relationship between resistance and temperature. So we have two types of thermistor. We have NTC and we have PTC. So NTC stands for negative temperature coefficient. The resistance decreases with increasing temperature. So basically, when the temperature increases, the resistance will decrease. For PTC, positive temperature coefficient, resistance increases with increasing temperature. So it means that as the temperature increases, the resistance will also increase. So how do thermistors work? Thermistors change resistance exponentially with temperature. They are made from ceramic compounds and metal oxides. So these are some of the metal oxides used. Later we will see. And then the metal wire, the metal oxides are cascade in a glass. The non-linear behavior makes them sensitive to small changes in temperature and resistance. So these are some of the thermistor that we're going to use in the industry. We have bead type, we have probe type, we have disc type, we have washer types, and we also have screw types. Next, we're going to see about when do we use thermistor in industrial application. So first we have HVAC system, then we have medical thermometer, and we have automotive engine. So why do we use thermistor in industrial application? First of all, it's because of the cost. It is very cheap to reproduce as compared to RTD. So let us see, for example, for HVAC system. So this is an exhaust fan. And first of all, we're going to talk about NTC. So as the exhaust fan temperatures goes up, the resistance will also go down, and therefore the AC will turn off. As the temperature goes down, the resistance will go up, and therefore the AC will turn on. But for PTC, it's the other way around. When the temperature goes up, the resistance will also go up, and therefore the AC will turn on. But if the temperature goes down, the resistance will also go down, therefore the AC will turn off. So repeat this as many times as you want, and just get a general idea of what NTC and PTC is. Next, we're going to talk about RTD. So what is RTDs? RTD stands for resistant temperature detector. It is a type of temperature sensor also. It is often referred as resistance thermometers. It works on a basis of change in resistance of metal due to changes in temperature. RTD is used in a variety of applications and is preferred over other types of temperature sensors for its accuracy, ease of use, repeatability, and cost. Okay, so we're going to talk just now about why we use RTD as compared to thermoresistor because of accuracy. So as compared to the thermistor just now, it is a little bit less accurate, but the cost is lower. But for this one, accuracy is very high, but the cost is also higher. So temperature sensors are used across different domestic and industrial applications. So here we're going to see some of the examples of RTDs in a probe. So RTDs are usually housed in a protective metal probes. So this is a probe. So inside of the probe there is RTD. So it is housed in a protective metal probe and can be threaded or flanked for industrial application. The wire here are connected to the thermometer, the reading thermometer part. So this is the example of RTD in industrial application. So we want to use this in industrial application, like for example in oil and gas refinery, for example, or maybe in food processing. So we want to make sure that it will go up to a certain degree Celsius that we wanted. So it is very important that it is to be accurate, so that we can achieve the desired temperature. Some of the examples also including just not for heating, this is heating. As for cooling, we have also refrigerator, for example for using of vaccine of COVID-19. So we want to make sure that the temperature of the vaccine goes into -5 degrees Celsius, for example. So we need it to be very accurate. It cannot be very low, it cannot be higher than 5 degrees Celsius. So yeah, so this is for accuracy. So we have several types of RTD. We have copper, we have molybdenum, we have nickel iron, and platinum. This is the one that inside here just now, the types of wire used. So next we also have by wound and thin film of RTDs. So this is the wire wound just now in the probe, we can see. This is the thin film for RTD. So let us compare thermistor and RTD. The temperature range of thermistors can go from -50 to 150 degree. Some can go up to high to 300 degrees Celsius. For RTD, it is -200 to 850 degrees Celsius. For accuracy, it is moderate because it has a range from 0.5 to 2 degrees Celsius. So it is a little bit less accurate as compared to RTD. RTD is very accurate because its range is only from 0.1 plus minus. Some can go even 0.05 degrees Celsius. For linearity, it is non-linear. So what is non-linear? So basically the graph, for example just now, it is not straight line, so it is probably like a slight curve like this, or probably a slight curve like this between temperature and resistance. As compared to RTD, it is very linear, meaning that it is very accurate. So we can see a clear straight line. For response time, for thermistor, yes, it is very fast. But for RTD, it is the response time can be taken slowly because you need it to be very accurate. So it cannot be accurate and fast at the same time. For material, we use ceramic and metal oxide, but for RTD, it's most probably we're using platinum. But of course, if you guys see just now, we have different types of RTDs as well. For cost, it is low. For RTD, it is more higher. For durability, fragile because it is made from the glass just now. For RTD, it is more durable because there are no glasses to be broken. For stability, it is prone to drift because also just now connected to linearity. But for RTD, it is stable over time. Now let us go to the question: when do we use thermistor or RTDs? For medical thermometer, do we want to use thermistor or RTD? We want to use the thermistor. Why? Because it is cheap. If we can produce a lot of thermistors, thermometer by using thermistor, we can produce them a lot more. So meaning that the thermometer will be cheaper and we can use it in hospital more, even though the accuracy is a little bit off, between 0.5 to 2 degrees Celsius. But the main thing is we can measure the temperature of a human body with certain limit, and also it will be cheaper. So that's why we use thermistor. For industrial control, what do we use? We want to use RTD because we want it to be accurate. Like for example, the bacteria is killed with 100 degrees Celsius, but if it's not accurate, like for example it is probably like 98 degrees Celsius, they are probably like some of the bacteria will be surviving in the food content in the food, and therefore there will be serious problem. Consumer electronics. So we already talk about consumer, so we need to be lower cost, so that's why we're going to use thermistor. I think you guys have an idea of how to handle which one do we use, whether we want to use thermistor or RTD. So next, let us see about the lab environment. Which one do we want to use, thermistor or RTD? So yeah, we're going to use as the same as industrial control. We want it to be very accurate in lab environment, so we want to use RTD. For HVAC system, this is a special case, because in HVAC system, like we have two types of HVAC system. One is for consumer and one is for lab. Like explained just now, whether we want to use it for vaccine, to keep the vaccine in a cold storage. So for consumer, we want to use thermistor, the air conditioning that you use in your house. But for lab, we want to use a good refrigerator, so we want to use RTD. So both can be used actually. In a nutshell, thermistor is cost effective, sensitive, but not non-linear, meaning that it is less accurate, suitable for consumers. For RTDs, it is accurate, stable, fast response, and ideal for precision measurements. So you want to use thermistors and RTDs based on accuracy, on the temperature range that you wanted, the budget, and the environment. Thank you very much. That's all for me.